Okay, cool. Hello, everyone. I'm Caroline. I'm the current president of WKU Jump Rope, and I'm going to be sharing my honors capstone thesis project with you all. So the title is Jump In to STEM, Connecting Jump Rope to Engineering. Hello, change please. There we go. Okay, so the overall goal that I had for my project was to connect the three things that I really enjoy doing: jump rope, engineering, and teaching. And so I kind of just started out my sophomore year brainstorming ideas, and the thing that I came up with in the end was to try to investigate some of the relationships between jump rope and engineering, and then use some type of teaching method to kind of show those relationships to other jumpers and help spread my findings to that way. So a little bit of the background of the project of why I thought it would be really useful, and how I came to the project as a whole that I landed on. And like Simone said this morning, most of the sport is girls, and with STEM in specific, there's a ton of STEM disciplines where girls are still underrepresented. Goodness. And so I thought this project would be really useful, because teaching STEM to a sport with mostly girls, and so it would have that benefit in it. Another key thing about the project was that jumpers are already learning from one another. This morning when we did the workshop, we were learning from other jumpers. And so yeah, when for my project, when I would be teaching the lesson plan, it would be me, a jumper, teaching other jumpers. So it would be a very similar concept, just adding that extra STEM element into it. So the next step that I did in the project was just researching the sport. There, some of y'all are presenting, there are jumpers that are researching the sport already. I started this project in 2018. And so a lot of the research that even if jumpers were doing, it just wasn't really shared in the community super well. And so I also pulled research in from a lot of other different sources. So one of the things I looked at was other programs that had connected STEM to other sports. And so there's one that I looked at that was gymnastics, that was super helpful in giving a basic structure for the lesson plan that I was developing, because they were also creating relationships between basic gymnastics concepts and basic STEM concepts. There had also been a little bit of research on the sciencey physics side of jump rope, not a ton, but there was one study that had looked at the aerodynamics of a rope, which was in mostly terms that as an engineer I didn't understand. And so I figured that it probably wouldn't be best for me to try to teach those concepts in a lesson plan to high schoolers. So that I was able to use to find some of the variables that I would want to test, but it wasn't super applicable otherwise. And then the other part of the research that I did beforehand was looking into high-speed photography. I'll talk a little bit more about that later, but it was something that had been used in the past to study jump rope a little bit. So for my project, I looked both qualitatively and quantitatively at the sport, and then combine that into a lesson plan. So I'll go over each of those elements a little bit. So the first part is I talked to just different jumpers and kind of got their idea on some of the relationships they saw between STEM and the sport from the lens that they had the most experience in. So I talked to Kaylee about the exercise science realm. I talked to some of my other friends about their majors, so math and biology. I took some of my experiences as an engineering major. This video doesn't look like it's playing. Go to the next one. And so yeah, so I'll just go over a few of the examples that I found from that. So one is energy and inertia. When the jumpers turning for the turntables. They're like bringing their legs in, which reduces the amount of energy it takes for them to spin, which makes it easier. Also, geometry is involved in a ton of jump rope tricks, especially long rope ones like this. So this is triangle, where jumpers need to know like angles, obviously like number of ropes and jumpers that they can have, and basic skills like that. Momentum is another one. This is a little like less explicit, I guess, but the rope, when you're jumping, I feel like we all know that it wants to keep its momentum going. And a lot of the times when you jump, you just have to let the rope do whatever it wants to do, and you like follow its course. So just keeping the momentum of the rope up that way. Also, waves is another big one, especially with double dutch. A normal like set of double dutch ropes is just half of a wave. So each turner would be a node. And then in this trick, you would have a full wave where there's an extra node in the middle. So yeah, so those were just some of the concepts that I had discussed from other jumpers and talked about and learned. So moving on to the more quantitative section of the project, I was testing 4 different variables in front of just like a blank screen with a high-speed camera and recording myself and then going back to look at the data. And so picture of my ropes are on the left, the setup I use is on the right. And then to count my jumps to make sure I was going the same speed, I was using the tally jump sensor that Tori made. So yeah, this is just the setup I was using to help determine. I tried without a high-speed camera. It didn't really work. But eventually I got the process down, so I was getting consistent results and had the setup pretty well determined. So these are just the different variables. I first looked at the width between jumpers' handles, so like how far they like hold their arms apart from one another. And then for each of these variables, I did 3 or 4 different combinations of like a handle type and a rope. And then I kept the like length constant for each trial that I was doing. That makes sense. So these are the set. Next variable I looked at was the length of the rope. So I used a short, long, and normal size rope length. And that was just based on like the normal size rope I used, then longer and shorter. And then the next one was looking at the different types of handles, and that was all jumped with the same rope. And then the different types of ropes with the same type of handle. So after I recorded a bunch of trials, I started to look at the data. And so as I was going back through the footage, I was looking at like how the rope was interacting with the ground, the arc of the rope as it was like moving back over my head. And yeah, those were like the main 2 things I was looking for as I was looking at data. And so, I guess I can talk about what I found. That would make sense. And so from me looking at the like 4 different variables, I found that for the width that a jumper holds their handles, the rope is connecting more with the ground when a jumper holds their hands narrower. And so that leaves a greater like impulse. And so the rope is like losing more energy as it's hitting the ground. And like the arc of the rope is more disrupted when like it's hitting the ground and like having to come back up over the jumper. For the length of the rope, it's kind of similar. But for that one, I noticed that the rope was pretty much going at the same speed for all of the trials, which I was jumping at like the same pace to keep that consistent. So that was good. But then I realized that even though the rope was going at the same speed, if the rope was longer, more of it was like more of the rope was like hitting the ground. And so it was once again losing energy there. And so I just figured out that in order to make up for that energy difference, so the rope would still be going the same speed, the jumper would need to apply more work and like use more energy themselves to keep the rope turning at the same speed. For the difference in handles, I really couldn't notice a ton of a difference from just using the high-speed video analysis. And so that is something that I think like definitely does play a factor in a jumper and their performance. But I think it would just need another technique to analyze it, possibly something to like measure how much effort a jumper is putting into turning the rope. And then I wanted to look at the type of rope, but I wasn't able to get enough data for that to actually like make meaningful results, and just wasn't able to jump because I didn't have a ton of opportunity to jump last semester. So those were like the overview of what I found. Okay. And then, so yes, I compiled both of the results from me talking with jumpers and their findings, and then the results I found quantitatively, and turned it into a lesson plan. I was hoping to teach it to jumpers, but that has not happened yet. Hopefully it will fairly soon. And so yes, the lesson plan, I use an active style of learning. So jumpers are used to being active at practice. So I figure they might as well be active when they're trying to learn. And so I just base the lesson plan off of that. So that is just an overview of my project. If y'all have questions, you can type them in the chat. I know we're fairly short on time.
Thanks, Caroline. This was awesome. Let's go